All right, good morning or afternoon, students, whenever it happens to be for you. Today we are working on IXL Skills K1, K2, and K3. You have done all of this before, and again, it's all a good refresher of skills that you should know and love. I am thinking that you're taking notes as you watch these skills. But maybe you don't need to. That's really your choice. But it is probably a good idea to watch these videos and just make sure you remember everything. So first of all, we have classifying polynomials by number of terms and degree. And so I have some vocabulary here, which I'll talk about in just a second. And then also you want to make sure that when you're doing these IXL skills that you are showing your work. And whether you're using paper or creating your own little whiteboard where you can write down the problems and do the work on your little whiteboard and then erase it, you can't do this stuff in your head. You have to write stuff down. So whether it's on paper or whether you make your own little whiteboard, it's your choice. So first, let's review some terms, vocabulary for polynomials. Polynomial, really, literally the word poly means many. And we use nomial technically means names, but we use it in math as terms. So this technically translates to many terms. And many can mean a lot of different things. So we have special names. Again, monomial. Ma means one. So here's an example of a monomial. It has one single term. It also happens to be linear. So degree is the highest power of your variable, whatever that happens to be. And so when it's x to the first power, like this one is x to the first power, that is also a linear function. So this is an example of a linear monomial. Binomial means two. And so here you see we have one term and a second term. So there are two terms here. And it also happens to be an example of a quadratic function. It's quadratic because it's x to the second power. That highest power is 2. And here we have a trinomial. You can see here is one term. Here is a second term. And here is a third term. So it is a trinomial. Tri means 3. It is also an example of a cubic function because the highest power here is x cubed. That highest power is 3, and that's what we call a cubic function. So hopefully you remember those terms and those special words. And so example 1, again, you can pause this video at any time if you need to write down the questions. Just pause and write everything down and then start it up again. I'm going to not give you time to do that because you have the ability to pause. We want to classify by degree and number of terms. When you're doing these IXL problems, please just make sure you read the directions. It doesn't ask for both all the time. So you can see here we would have 1, 2, 3, 4 terms. I don't have a special name for that, but for this one, they probably are just asking you to input 4. But we don't have a special name for that one. We only really have it for 1, 2, or 3 terms. And the degree is the highest power of our variable. So we have s being cubed here. So that degree would be 3. And if we wanted to give it a special name, we would call it cubic. And so I'm not sure which one it's going to ask for, but read carefully. It's either the number 3 or it's the word cubic. All right. This negative 4h squared has one term. And if we wanted to give it a special name, we would call it a monomial. So I'm not sure which one it's going to ask for. One term or monomial. And if we want to classify it by degree, the degree is h being squared. So we could have a degree of 2, or the special name, if it's degree 2, is quadratic. So again, any of these words are what you would be selecting or inputting for numbers. Now, this is a very special one. This has lots of powers and it has lots of variables. It doesn't just have a single variable like S or H or X. Instead, it's got lots and lots. And this is a special case. So first of all, we have one term, two terms, three terms. So three terms, we could call it the number 3 if it asks how many terms. Maybe they're just asking for 1, 2, or 3. Or we could call it a trinomial. Tri means 3, trinomial. So I'm not sure which one it's going to ask for. And if we're classifying it by degree, this one is very interesting. What we do is we basically look at the term and add up all the powers. So R has its own little power of 1. And if I want to find the degree of this function, I just have to add up all of these powers. So 2 plus 1 plus 4, that's going to give you a degree of 7. Here, 1 plus 1 would just give you a degree of 2, and this is q to the first, that would be a degree of 1. So we go with the highest sum of powers. This is a degree 7. We don't have a special name for that. But that is a different kind of question. We haven't seen one of those before, but it'll pop up on the challenge portion. So kind of interesting there. So sum of powers on the highest one, the biggest sum of the terms. Okay. Example 2, add or subtract. We are adding and subtracting polynomials. Addition is super easy here. We are just combining like terms. These parentheses aren't really necessary when we have addition. So it's really just q minus 6 plus 8q squared plus 8q. And we just need to combine like terms. Like terms have to have the exact same variable with the same exact power. So my only like term here is the 1q and the 8q. And I'm not sure if they say write it in standard form, but it's typical that we write our powers in descending order. So I'm going to start with our 8q squared. I'm going to go ahead and combine my like terms. 1q plus 8q's is 9q's. And then I have my negative 6. And there is my answer that I would put in. Make sure you don't forget your powers. Don't forget to write a q. Make sure you're taking your time as you input these answers. It's really frustrating when you input in your answer 8 squared plus 9q minus 6 because you're rushing and you forgot, whoops, the q in there. So that's frustrating when you get things wrong because of a typo. Now, when we are subtracting polynomials, subtracting is much more difficult. We are subtracting everything, and so you need to remember to distribute your negative, all right? And that is the tricky part when you have a negative. I don't need to distribute to the things in front, so I can just drop those parentheses, but I am subtracting everything behind the negative sign. Negative times negative turns to a positive 6a to a fourth. Negative times negative a cubed turns to positive a cubed. Negative times positive 4a squared turns to negative. Negative times positive is negative. Really just means change all the signs, the opposite. Negative times negative 7a turns to positive 7a, and negative times positive is negative 9. So it's really just changing all of those signs because it's really saying take the opposite. Now we can combine like terms. 6a to the fourth doesn't have any friends, so 6a to the fourth. We have positive a cubed. Doesn't have any friends. Again, I have a negative 4a squared with no other like terms. So he stays. Now I've got something. I have a negative 9a and a positive 7a. A negative 9 and a positive 7 means there's 2 negatives left over. So negative 2a for that one. So I'll underline it. And I have a negative 5 and a negative 9. So a whole lot of negatives. It's 14 negatives. So make sure you're adding carefully, and that's what you'd want to enter in IXL. So again, addition is always easy. Just combine like terms. Subtraction, distribute your negative. Be very, very careful. And then combine like terms. And the last thing is finding the product. Product means multiply. All right, so here we have negative 4v times the quantity, negative 3v squared plus 4. We're going to go ahead and distribute. Negative times negative is positive. You don't have to write the positive. 4 times 3 is 12, and v to the first times v squared would give you v cubed. Remember, when they have the same base, you get to add your exponents. And then we're going to distribute negative 4v times 4. Negative times positive is negative. 4 times 4 is 16v. So positive 12v cubed minus 16v is what we would type into IXL. And again, I cannot combine those because they're not like terms. This one is v cubed. This is v to the first. They don't combine. All right, again, I'm going to distribute. Negative w times 2w squared is a negative times 2 is negative 2. W times w squared would give you w cubed. Negative w times 3w would be negative 3w squared. W times w is w squared. And here we have negative w times negative 2. Negative times negative is positive. W times 2 is 2w. No like terms there. And then the last one, I just wanted to remind you, this is quantity squared, which means it's repeating 2 times. Repeat the base 2 times. So this means r minus 2 times r minus 2. And we want to distribute. So you need to distribute the r, and you need to distribute the negative 2. Distribute everything to everybody else. So r times r is r squared. R times negative 2 is negative 2r. Negative 2 times r is, again, another negative 2r. And negative 2 times negative 2 is positive 4. And on this one, we can combine like terms. So I get r squared. Negative 2 and a negative 2r and negative 2r is negative 4r's. And then we have our plus 4. So here is our simplified answer. So again, it says simplify. That just really means that you need to combine like terms carefully. Watch those negatives. That's where they're going to try to get you. So pay close attention, ladies and gentlemen. And remember, if you get something wrong, there is an explanation. And please, please, please read those explanations. Take the time to figure out what you did wrong. Don't just go got it and move on. Try and figure it out. That's where most learning takes place. All right, ladies and gentlemen, you should be able to do K1, K2, and K3. Have a great day.